Welcome back to Science Now, our show all about science and physics. I'm your host, Aahil Abdul Nazeer, and today I'm joined by Dr. Arya Naidu, prestige scientist in the physics field. Welcome, Doctor. It's nice to meet you. So for today's topic of interview questions, we're going to be talking about infrared light. For our first question of the day, Mr. Naidu, what is the size of infrared light?
Well, the size of these waves tend to vary from around 700 nanometers to around 1 millimeter, or it's about the same size as the tip of a pencil point.
For our second question, in what ways is infrared light similar to visible light, and how is it different?
They're both part of the electromagnetic spectrum. This means that they have similar aspects like being focused, reflected, or polarized, like with a laser pointer. There are many differences between these two types of lights as well. Unlike normal light, infrared light cannot be seen by the human eye, and instead can be felt only through heat.
Our third question, describe at least two important uses for these waves.
Well, two important uses for these waves are for thermal imaging and heat sourcing. For example, temperature sensors and thermal imaging cameras use infrared lights by scanning the heated surfaces of the objects to find their temperatures. An example of this is a thermoscope AR from Fortnite. Additionally, communication equipment like remotes, for example, also use infrared light to communicate signals and information to other devices like your TV that you're watching from right now.
Question 4. Are these waves of infrared light harmful to us?
Infrared light is more powerful than normal light. It can damage the lens, retina, and other parts of the eye, which is very dangerous for humans.
And for our fifth and final question of the day, Mr. Naidu, what is thermal imaging and how is it used?
Thermal imaging uses infrared light safely to measure the temperature across the surface of an object. Essentially, we can use thermal imaging cameras and their infrared lights to scan unknown regions of the Earth and see if they have optimal or too hot conditions for us to live on.
It's time for our bonus round of questions. If you don't mind, please explain to us what the electromagnetic spectrum is and how it's used.
Well, the electromagnetic spectrum is a range of light that interacts with different objects. For example, the visible light is different from infrared light because infrared light has a longer wavelength.
What about data? Like with radios or cell phones. How do they put data into these waves?
Now, the wavelength of the electromagnetic wave determines what objects are going to interact with it. But the amplitude and frequency of those waves determine the data that's being sent through those objects. As an example, let's take a TV and a remote. The electromagnetic waves from the TV remote is specific in wavelength to talk to a TV. However, its amplitude or the height of the wave itself varies based on what the remote is trying to say for the TV. For example, increasing the volume may result in a higher amplitude, while decreasing the volume may send a lower amplitude wave.
That was very interesting, Dr. Naidu. Thank you so much for letting us interview you. Really appreciate you coming out today on Science Now. Welcome back to AA Animations. I'm Aahil.
And I'm Arya, and today's video is going to be about cell phone communication.
Ready? Let's go!
Well, let's assume that we're sending a text message via cell phone to another person far away. There are 5 steps to do this. The first step, the person 1 encodes the information into the cell phone. Second, person 1's cell phone sends its data to tower 1. Third, tower 1 sends the cell phone data to tower 2. Fourth, tower 2 sends the data to person 2's cell phone. And finally, step 5, person 2 sees the data.
Let's start with step 1. Person 1 decides to text some information into their cell phone, which we'll call cell phone 1. At the moment, that information is in binary and is stuck inside the cell phone.
Step 2. In order to wirelessly transfer the data into the cell phone of the other phone, it has to convert that binary data using chemical energy into radio waves and send that data into a cell phone tower.
Step 3. Once the data travels to the first cell phone tower, that radio wave frequencies of data gets converted into light waves. Why light waves? So they can be sent through fiber optical cables really fast to the next cell phone tower, as fast as 2.4 or 5 gigahertz.
Step 4. When the data has reached its last cell phone tower, the tower will convert the light waves of the data back into radio waves and wirelessly send it to cell phone 2, our receiver.
Step 5. And finally, the cell phone will receive the radio waves and convert the data back into binary, revealing the text that the first person sent. That's how cell phone communication works. Thank you so much for watching the video.
And don't forget to like, comment, and subscribe.
Up next on Physics Features, we got number 1 on the top 100. Transfer it, baby.
I sent a text to herself. Don't ask who, I'll never tell. I look to see what I sent, thousands of miles away.
From binary we must switch, radio waves make it bliss. You might not know how it works, but I'll tell you this way.
Cell phone towers holding radio waves that flow in light waves, then just going
through some fiber optics, baby. Hey, cell phone tower, Just don't be lazy. Please take this data, transfer it, baby. Just using light waves through cables, easy. Just take this data, transfer it, baby. Hey, cell phone tower, radio waves come daily. Use fiber optics and send it, baby. 2.4 gigahertz, it's super speedy. So take that data, transfer it, baby.
What did I just watch?